Hello students, welcome to Abhyas IIT Prep. This is Satyanarayana, Maths IIT faculty in Abhyas Edu Technologies Private Limited. Okay, now in this session, we are going to explain some previous questions got in JEE Mains 2024. Okay, now the topic is permutations. Okay, students, right. Now from this topic, we got one question in 27 January 2024 in shift 2. The question is, let alpha equals to 4 factorial whole factorial by 4 factorial whole power 3 factorial. And beta equals to 5 factorial whole factorial by 5 factorial whole power 4 factorial. Then which is the right option that we have to find? Okay, students, now all of you try to understand this question. Here alpha is given as, right, alpha equals to alpha equals to 4 factorial whole factorial. Now, the 4 factorial means already we know 24. Now, whole factorial is there. By, now I am writing it as 4 factorial whole power 3 factorial is nothing but 6. Okay. Now, if we see this, okay, I can write this as 24 factorial. By observing this, we cannot identify. Okay, so but when we expand this denominator 4 factorial whole power 6 as like this. Now I am writing this as 4 factorial into 4 factorial into 4 factorial into 4 factorial into 6 times I am writing. That is the meaning of whole power 6 now. Okay, now by observing this, here we have one formula, we have one concept in division. If we saw this, we have one concept better. For example, I am taking 5 objects. When I am dividing 5 objects into 2 groups, one group contains 2, another group contains 3. Here, the number of ways will be 5 factorial by 2 factorial into 3 factorial. Is it right? Okay, so we have the proof for this also. Because I have 5 objects, I want to divide that 5 objects into 2 groups. Is it right? When I am selecting group containing 2 objects, this can be written as like this also. If I am selecting 2 objects, automatically the remaining 3 objects will be separated. Is it right? So this is the concept division rule. Similarly, here also what it indicates? It indicates that total I have 24 objects. I am dividing these 24 objects into 6 equal groups, and each group contains how many objects? 4 objects. Is it right? That is the meaning of this. That means when we converted this mathematical expression into words, then it will be like this. The meaning is I have total 24 objects and I am dividing that 24 objects into 6 equal groups where each group contains 4 objects. Is it right? Then only we write this. And one more thing is also there better in here. So these 6 are identical. Identical means when we write like this by 6 factorial. Is it right? So for this structure we write this. But in the question they are asking only 4 factorial whole power 6. This is division rule. Now division means finally we get a natural number. That means this total belongs to a natural number. But according to the question, we don't want this 6 factorial. Now I am taking 6 factorial this side. Here already it is a natural number, means when I am taking this side into 6 factorial, some natural number into 6 factorial means finally we get a natural number. So that means alpha is a natural number. Similarly, now coming to beta. Okay, now coming to beta, we can write, okay, 1 minute. So similarly for this beta purpose also I am taking the structure. Okay, so here in beta we have 5 factorial whole factorial. So that means 5 factorial is 120. Now I am keeping that factorial as it is. Okay, by 5 factorial whole power, right, 4 factorial is nothing but 24. Okay, now if we observe this we cannot identify, but when we expand the denominator, Okay, now we can write it as 120 factorial by 5 factorial whole power 24 is nothing but we have to multiply 5 factorial 24 times. Is it right? So now I can write like this, 5 factorial into 5 factorial into and so on. 5 factorial how many times? 24 times. Okay, so here also what we are doing, here we have total 120 objects and we are dividing 120 objects into 24 groups in which each group contains 5 objects. That is, this is also again division. Division means it is a natural number. And here these 24 are identical. We write by 24 factorial according to division rule. Finally, this is division means it is a natural number. If you have a doubt, for example, sir, why we are saying this is a natural number? Okay, I will explain with one example. For example, I have 5 objects and I am dividing these 5 objects into 2 groups, each of which contains 2 and 3, let us suppose. Now, according to the division rule, what is the formula? What is the answer here? 5 factorial by 2 factorial into 3 factorial. If you simplify it, 100% we get a natural number. Is it right? So that is also here also same natural number. Now, according to the question, we don't want this 24 factorial. I am taking this side. Now, natural number into 20 factorial means 24 factorial means finally it is a natural number. Okay, so finally what we are saying, beta, alpha is a natural number and beta is also a natural number. So which is the right option? Option C is the right one. Okay, so I am repeating once again, in this problem we are using only the division rule. Okay, division, with the help of division rule we can solve this problem. Okay, friends, now we'll move to the next question. Okay, understood? Right. Next question. Now see this. Here the question is, all the letters of the word G20 are written in all possible ways with or without meaning, and these words are written as in a dictionary. Next, now the serial number of the word G20 is, okay, here the word is G20. Sometimes they will ask, find the rank of the word also. Okay, friends. Now, rank of a word is nothing but, for example, one word is given. So, in that word, some letters will be there, na beta. Okay, when we arrange the letters in the given word in dictionary order, then what is the number of the word? That is called rank. Okay, so it's here. So that is only given here. We are arranging the letters of the word G20 in a dictionary order. Now we have to find the serial number of the word G20. This is nothing but we have to find the rank of the word. Okay, so it's here we have a lot of methods to find the rank of a given word. Okay, I will explain one short method. Okay, so here the method is, first what is the given word? G20. Okay, I will write the word first, G20. By giving some space, I am writing the word. Okay, G20. Next, above the word, I will take alphabetical order. Okay, now tell me what is the alphabetical order here? E, G, N, T, T, here T is repeated twice, T, next Y, sorry, W. So here it is after T, W, here it is Y. Okay, so first I taken word. Above the word, I am taking alphabetical order. Okay, students, all of you listen carefully. So here, I am taking two operations. The operation is, so in word, I will use circle. Right? I will use circle. And in alphabetical order, I will use cancellation. Okay, students, I am repeating once again. In word, circle. And in alphabetical, I will cancel that letter. Okay, so first in word, here rank equals to, now in word first I am circling the letter G. In alphabetical order, cancel G. Okay, now before G, here how many letters are there? Only one letter. Now 1 into, now here remaining letters except this G. So here the remaining letters are 6. Now in these 6 letters, we have to observe, is there any letter is repeated, including this. On counting, we cannot include this, but repeated purpose, we have to include this also. Okay, so here the remaining letters are 6. So 6 factorial. In that 6 letters, T is repeated twice, including this G. So 2 factorial. Okay, so it's next plus. Now I'm circling the word letter T in word. Next cancel first T only, not last T, first T. Now before T, how many letters are there? 2 into, now remaining letters. Here the remaining letters are 5. In that 5 letters, is there any letter is repeated? Including this we have to observe. Right? So in that T is repeated twice. So we have to write it as 5 factorial by 2 factorial. Okay, students. Next after that, plus W. I am circling that letter. Next cancel that letter in alphabetical order. Now before W, how many letters are there? 1, 2, 3. Now 3 into, remaining letters are 4. In that, is there any letter is repeated including this? No. All are distinct only. So we'll write 4 factorial. Next after that, plus E. Okay, circle it and cancel it. Before E, there is no letter. So that means 0. Next plus I am circling the letter N and cancel that N. Before N, there is no letter. So that is 0. Next T round up. T cancel. Before T, there is no letter. Next Y round up, Y cancel. In the last, we have to write it as 0 factorial. Okay, so 0 factorial is nothing but 1. Okay, so this is the concept. Okay, after that we can do the simplification. There is no problem with that. Only this structure is important. Okay, so I'm saying once again, so whenever to find the rank of a word, first we have to write the word, above the word we have to take alphabetical order. Okay, this is very smart method. Okay, students, we have descriptive method also, but by taking descriptive method, solvation will be take more time compared to this. Okay, so here in word we are taking circling, and in alphabetical order we are cancelling the letter. Okay, so after that, now what is the answer here? 6 factorial means 720. 720 by 2, this is 360. Now 5 factorial, 120 by 2, so 60 into 2, 120. Next 24, 4 factorial, 24 into 3, 72. In the last 0 factorial means it is 1. Now adding this, what we are getting here? 360 plus 120. So that is 480. 480 plus 73. Now take calculation. 480 plus 70. That will be the final answer. Okay, 553 is the rank of the word G20. Okay, students. Right, we have few more problems are also there. They are asking regularly in the NTA mains examination. So when the word contains non-repeated letters. Okay, here coming to in this word G20, one letter is repeated twice. Okay, already we know some letters are identical, some letters are different. In that case, we write how many times it is repeated, that we have to write in the denominator. Is it right? So this is the concept. Okay, so yes, this is the procedure to find the rank of a word. Okay, right. Next, now we'll see the next question. Now see this question. We got this in 29 January 2024, shift 2. Okay, the question is number of ways of arranging 8 identical books into 4 identical shelves where any number of shelves may remain empty is equals to. First, try to understand this question. Okay, here what is given? 8 identical books are there, right? Same books. Let us suppose mathematics books, right? 8 identical books into 4 identical shelves. Here shelves also identical. Now we have to arrange these 8 books in 4 shelves such that any shelf may remain empty. That means we can keep the shelves as empty also. Okay, here for this also there are 2 methods beta. Okay, I will say one method. Okay, 8 identical books into 4 identical shelves. For example, these are the shelves. 1, 2, 3, 4. Okay, right. So here we can keep any shelf as empty. Okay, first I am writing the cases here. First, I have total 8 books now. So I am taking one. So first I am taking one case. Is I am keeping 3 shelves as empty. 3 shelves as empty. This is my first case. Right? When 3 shelves are empty, now what is the case beta? So 8 comma 0 comma 0. Is it right? Here no need to arrange this because all these are identical. That means what is the meaning of this? So we cannot take like this beta. 0 8 0 0 is no need to consider this. Okay, when the shelves are different, right, dissimilar, then we can arrange this. But here in this case shelves are identical, so no need to arrange this. Simply we can take 8 0 0. Okay, right, this is not needed. Right, this is one way when I'm keeping 3 shelves as empty. Okay, next now I'm taking the another case. For example, I'm keeping 2 shelves as empty. Okay, 2 shelves as empty. Right. Now in this case we'll see 2 shelves as empty means I can write, for example, 1 7. This is one way. Okay, 1 7. Next 2 6 3 5 4 4. Okay, 3 5 4 4. Next I cannot take 5 3 because if I taken 5 3 then that will be arrangement. But here shelves are identical. Okay, so that's why here the cases are, how many cases we are getting? 4 cases. Okay, when 2 shelves are empty, there are 4 ways. When 3 shelves are empty, there is 1 way. Okay, next now we'll see the third case. The third case is 1 shelf is empty. Only 1 shelf is empty. Right, now in this case we'll see. Okay, 1 shelf is empty. Now what are the cases here? For example, with 1 already 1. Okay, I'm taking here with 1 I can take only 1 shelf is empty. So 1 1 6. Is it right? This is one way. 1 1 6. Next 1 2 5 1 3 4. Next 1 4 3, that is also already included here only. Next 1 5 2, that is also included. That means it is arrangement, arranging the digits among themselves. So no need to consider because shelves are identical. Now 1 3 4 with 1, these are the cases. Next now I will take with 2 2 1, already 2 1 is included here. So no need to write. Next 2 2, okay, there is no way. So 2 2 4, this is 1. Next 2 3, right, 2 3 3, this way is not included. Okay, 2 3 3. Next 2 4 2, already included here. 2 5 1, it is also included. Next if you take 2 6, that is included here also, so no need to consider that 2 6. Okay, with 2 completed. Next after that, now we'll say with 3. Okay, with 3 3 1. if I taken 3, 1, 4, that is also included here. 3, 2, that is also included. 3, 3 included. Next 3, 4, that is also included. Next 3, 5, it is also included here. So with 3, there is no way. So this is not possible. Next, so these are the ways. So finally, how many ways are there when we are keeping one shelf as empty? So these are 5 ways. Okay. Right. Next, now I am taking no shelf is empty. That means I am filling each shelf with at least one book. Now in this case, how many ways we'll see? Right. This is 4th one. No shelf is empty. No shelf is empty. Right. Now in this, what are the cases here? I can take 1, 5. Okay, 1, 1, 1, 5. The way is not included. Okay, 1, 1, 5. Next, 1, 1, 2. Now 4. 1, 1, 2, 4. Next, 1, 1, 3. 3. Okay, 1, 1, 3, 3. Next, after that, 1, 1, 4 means 2, that is already included here. This is way. Next, now I will take with 2, 2, 2, 2. Okay, that is not included in any way. So next, can I take 2, 1, 2, 1, 3? So with that, 2, 1, 3, 4. Sorry, 2, 1, 3, 2. This is also not included. Is it right? 2, 1, 3 plus 3, 6 plus 2, 8. So these are the, how many ways are there? 5. So totally 1 plus 4, 5 plus 5, 10 plus 5. So 15 ways. So which is the right option? Option B is the right one. Okay, so here we have to write the cases carefully. There is no alternative way. Okay, because when, for example, here these are 4 different, so 4 different or dissimilar shelves, then we have a lot of formulas. Some non-negative integral solutions or integral solutions concept. With that concept we can solve. But here, when identical word is included, compulsory we have to write the cases. Okay, so yes, this is the question. Right? The next question is, if n is the number of ways in which 5 different employees can sit into 4 indistinguishable offices where any office may have any number of persons including 0, then n is equals to. Okay, so if you see, the question is, there are 5 different employees. And we have to arrange these 5 different employees in 4 different offices such that the office may have 0 persons also. This is the question. Okay, so now here total employees are 5 and we have to divide these 5 employees into 4 groups because we have to arrange these 5 persons in 4 offices, right, such that the office may contain 0 employees also. That means here we apply division rule. Okay, right. Now one way is I am dividing 5 employees into 5, 0, 0, 0. Now these are different offices, so that's why we can arrange these. In how many ways we can arrange? Here 5 factorial by 5 factorial. That is 1 we are getting. Next, the another way is I can take 4, 1, 0, 0. That means, okay, here now I am keeping 2 offices as 0. Now in this case, 5 factorial by 4 factorial. It is 5 only. Next, 3, 2, 0, 0. So here 5 factorial by 3 factorial into 2 factorial. So 120 by 12, it is 10. Next, with 2, again we get this only. So these are the cases for keeping 2 offices as 0. Next, I will take 1 office as 0 employees. So in that case, we can write 1, 1, 3, 0. Okay, so here the ways will be 5 factorial by 3 factorial, but in this the employees in 2 offices are identical same, so that means this is repeated twice, so by we have to write, so it is 2 factorial. So with that what we get, 120 by 12, that is it is 10. 113. Next, now I am taking 1 2 2. Okay, in this way also we can arrange 1 2 2 0. Now here the ways will be 5 factorial by 2 factorial into 2 factorial. Here also the two groups are repeated twice, so by 2 factorial. Here it is 120 by 8 means 15. Okay, next, is there any other way? No. Right, so this is for keeping one office as 0 employees. Next, now I am taking no office is 0 employees. Right, no office contains 0 employees, means with that we can take 1 1 1 2. Okay, now in this case how many arrangements we can get? 5 factorial by 2 factorial, and here the employees in the three offices are same, that is repeated thrice, so 3 factorial. So with that what we get here? 5 factorial, 120 by, it is 12, 120 by 12 means it is 10. Okay, right, these are the final ways. Now add all these. Now what we get here? 1 plus 5, 6 plus 20, 26, 26 plus 10, 36 plus 15. So total ways are 51. Okay, students. So which is the right option? Option D is the right one. Okay, here we are using division rule. Okay, students, we'll see the remaining problems in the next session. Okay, students, thank you for watching.